This is problem 36 of chapter 16, called More Pets. It's also a quiz problem from time to time that I give. So we're going to use the information from problem 34. Okay, so we're thinking now about getting 2 dogs and a cat. Assume that the expenses are independent and have a normal described in the problem above, a normal description, a normal model as described above. Okay, so define the appropriate variable for the total expenses. So if we let T be the total, it would be D plus D plus C. Okay, it would be a little bit of a mistake to say, we don't want to say 2D plus C, because this a random event is happening twice. It's not like we have one dog and we're going to double the expenses. We actually have 2 different dogs. Okay, so I'm just going to get rid of that. Alright, so now they want us to describe the model, so that means we have to have a center mu. So that's the expected value of D plus C. So that's just 100 plus 100 plus 120. So that's going to be 320. Okay, and then to get the standard deviation, let's get the variance first. So the variance of D plus C. And this is where the payoff comes from understanding random variables. This is going to be the variance of D plus the variance of D plus the variance of C, variance of cats. Okay, so that's just going to be 30 squared plus 30 squared plus 35 squared. Okay, so the standard deviation is just the square root of the variance, so 30, whatever this is, 30 squared plus 30 squared. You can type this in. You could have typed it in over here and found the value. I'm just being lazy or theoretical. So that's going to be, I get $55. Alright, so now we have the model. So what is the probability that your total expenses will exceed 400? Show all computations and draw a model. Okay, so since the models for the independent up here, since we were told that these variables fall a normal distribution somewhere, right here, we were told that they can be described with a normal distribution. So then their sums can also be described as a normal distribution. So what we would have is a picture of something like this, and the center would be at 320. Okay, and I get lazy. I don't want to label these. It gets too cluttered, the standard deviation. So I use the notation 320 with a standard deviation of 55. Okay, so let's see. 400. They want to know what's the probability that these 2 dogs and cats, their medical expenses will be more than 400. So let's see. This is going to be about 375 right here. So it's going to be right around here somewhere. It's this area that we want to compute. So what's the probability that D plus C is greater than 400? Okay, well that's equal to the probability. So recall, Z equals X minus mu divided by sigma. So that's going to be the probability that Z is greater than 400, since that's what we're interested in, 400 minus 320 divided by 55. Okay, so I get I'll do it here. That's probability that Z is greater than 1.45 standard deviation. So I think I estimated that pretty close. Maybe it should, no, that's about right. That's about a little bit halfway. So I estimated that about right. That's 1 standard deviation. That's 2, so 1.45 is right there. Okay, so that's going to equal normal CDF of 1.45 to infinity. And I get 0.073 or 7.3%. Okay? So, according to the normal model, the probability that the medical cost of 2 dogs and 1 cat is greater than $400 is 7.3%. Okay, so that's how you do this problem. Define your variables, think through how the random variables work, and then calculate the expected value, standard deviation, and apply the normal model. Okay, there you go. Good luck.